going to have a deeper look into the unit circle. So again, I just want you to recall two things, which is at 30 degrees is pi on 6, 45 degrees is pi on 4, and 60 degrees is pi on 3. And we've got our two exact triangles. Okay? So let's have a look at the unit circle. We know that the unit circle has just got a radius of 1 and it wraps around the circle 2 pi times in terms of angles. The y-axis is sine and the x-axis is cos. 30 degrees is pi on 6. Now if you were to just take a slice of your unit circle 30 degrees around from its original position, there will be an angle of 30 degrees, which is pi on 6. Now, if you consider it from the other way it wraps around here, which is going all the way around that length there, and I'm going to get rid of that, is that is going around 30 degrees from 180 degrees. So we know that is going to be 210 degrees. However, in radians, it's pi plus pi on 6, which would give us 7 pi on 6. We can do a similar thing. Instead of 30 degrees, we can do 45 degrees. Slice that through our unit circle at 45 degrees. We know that's going to be 45 degrees here, and we know that is pi on 4. Now, we also know that we'd be going around the circle 225 degrees, because it would be 180 plus that 45 degrees we've just gone around. So this point here would be 225 degrees. To work out in radians, it's pi plus pi on 4, which would get us 5 pi on 4. Again, we can do a similar thing. Instead of it going around 45 degrees, we'll go around 60 degrees, slice it through. And we know that is going around 60 degrees, which is pi on 3. And this other guy here would be an extra 60 degrees around from 180, and that would give us 240 degrees. And to work out in radians, it would be pi plus pi on 3, which gets us 4 pi on 3. Okay, where we slice it through there, and that is going to be an extra 30 degrees around from 90 degrees. So we know that that is going to be 120 degrees around. And to work out in radians, it would be 90 degrees, which is pi on 2, plus 30 degrees, which is pi on 6, and that would give us 2 pi on 3. Again, we can do this with 45 degrees. And from the other end here, we know that, well, it's an extra 30 degrees around from 270 degrees, which would get us 300 degrees around the unit circle, and that would be 3 pi on 2 plus pi on 6. Now if we equated that, we would get 5 pi on 3. A similar thing applies if we were to do an angle of 45 degrees through. We would take our slice through, and we know that this point here is an extra 45 degrees around from 90, which gives us 135 degrees. And to work out in radians, it would be pi on 2 plus pi on 4, which gives us 3 pi on 4. And again, from the point 270, it's an extra 45 degrees around. So that gets us at 315 degrees. And to work out in radians, it would be 270 degrees, or 3 pi on 2 plus pi on 4, which gives us 7 pi on 4. And finally, we would do it for our 60 degrees around, okay, which would give us an angle of 150 degrees around from the start. This guy down here, 330 degrees. And similarly, to work out in radians, you would just get 5 pi on 6 and 11 pi on 6. Okay. Now, it's also important to notice here with our unit circle is that this is the x-axis and this is the y-axis. And also remember, tan of theta is equal to sine of theta divided by cos of theta. Okay, and so we can actually determine if the values of sine, cos, or tan are going to be positive or negative, depending on what angle we're at. And so typically we see in the first quadrant, that would be this guy up here, the first quadrant, is that x and y are both positive, or sine and cos are both positive. And if sine and cos are both positive, then tan is going to be positive also. So we would say that all of the values are positive there, and I'm just going to denote that as A. If we go over into our second quadrant here, we'd see that that's when x is negative and y is positive. So in other words, that's when cos is negative and sine is positive. And if cos was negative and sine was positive, to determine the value, the sign for tan, we'd have a positive divided by a negative, which would give us a negative. So in this quadrant here, only sign is positive, and I'm going to denote that as an S. We go down into our third quadrant down here, and we can see that X and Y are both negative, right? So that means that sine is negative and cos is negative. But to work out tan would be sine being a negative and cos being a negative. So you've got a negative divided by a negative, which would give you a positive. So in this quadrant, tan would be the only thing that is positive. We'll denote that with a T. And in our last quadrant here, the fourth quadrant, we see that sine is negative, but cos is positive. So that would give us a negative value for tan, because we've got a positive and a negative with that division process there, meaning that only cos is positive in this angle. And the easy acronym for this is CAST, where we say only cos is positive down in the fourth quadrant, everything is positive in the first quadrant, only sine is positive in the second quadrant, and only tan is positive in the third quadrant. So that's going to tell us whether sine or cos is going to be positive or negative. Now we're going to have a look at some examples for solving exact values using the unit circle. But firstly, in order to solve for an exact value of a trigonometric angle, we need to draw a unit circle with CAST labeled in their appropriate quadrants. We look at the angle that we're given and we draw out a unit of 1, that is the radius, a unit of 1, out from that given angle. When we're creating a triangle within the unit circle, we always draw our triangle to the x-axis. When you have your triangle, you would identify the special triangle in which you have to help you state your solution of sine, cos, or tan, and you would consider the negatives with the label as CAST. So we'll have a look at some examples and see how that works. So example 1 here, it says evaluate the exact value of cos of 2 pi on 3. Now 2 pi on 3, immediately, that's 120 degrees. In order to solve these ones, I'm just going to go through my flowchart. So first things first is drawing up the unit circle. And I need to draw out the radius at an angle of 120 degrees, which would be wrapped there, and that's 120 degrees there. However, we draw our triangle to the x-axis. So this would be our triangle that we've got here, and this angle in here would be a 60. So I'll draw this triangle out larger at the bottom here so I can see what I'm doing. So I notice that it is the special triangle of 30-60, where that means that I've got root 3 on 2 and a half as my side lengths. And now here I'm dealing with cos of 120 degrees. So I'll just zoom in here just so we can see this for a moment. And I'm dealing with this angle here. I consider that is my theta value. Okay, so that means when I'm doing my solution here, I'd say that I've got cos of 2 pi on 3. And I know that is going to be equal to, I know it's going to be the adjacent, which is this guy here, a half, over 1. Also need to be careful, is it positive or negative? Well, I saw that it's actually occurred in this S quadrant here. S means that only sign is positive, so that means that the value of cos is going to be negative. So we can simplify this down to negative a half. You can double check this on your calculator. You can just plug in, if you've got it in radians, 2 pi on 3 cos, or if you've got it in degrees, you just say cos of 120 degrees, you should get a half. Okay, so always double check that. Have a look at another one here. It says the exact value for tan of negative 45, so same process. Okay, since I'm dealing with a negative angle here, I go clockwise around to my unit circle, and I can see this is the triangle I've got here, where I know this is a unit of 1 because I'm doing the unit circle, and I've got another special triangle. It is the 45-45 triangle, so I'll draw that a little larger out here, not forget my CAST labels. Okay, and always keep in mind that it's this angle is the angle that we consider. So this is our theta when we consider the angle to read off. So now I've got tan of negative 45 degrees. Okay, and I spot it is in the cast, it is in the C quadrant for cast, so I know my answer is going to be negative here. And tan of an angle is the opposite, root 2 on 2, divided by the adjacent, which is root 2 on 2. Now if you do root 2 on 2 divided by root 2 on 2, you just get negative 1. So that means that we've got tan of negative 45 degrees being equal to negative 1. Again, put this on your calculator. Double check it. Your calculator will spit you out the answer. If you get negative 1 and you're happy with it, you move on. Okay, last example here, it says evaluate the exact value, should be there, the exact values of sine of 7 pi on 3. Now, a little bit different here. 7 pi on 3, we can do some converting here to get it into degrees. If you're uncomfortable with those radians, you multiply it by 180 divided by pi. Okay, so that's 420 degrees there. So we're dealing with sine of 420 degrees. So when we go to do our diagram, we're going to have to wrap this guy around a unit circle, 420 degrees. Which, really, if you go around 360 degrees, you've just done a full loop. And to find out the additional amount, you can do it in your head if you like, but I would go 420, subtract 360 degrees, and you'll be left over with 30 degrees there of 60 degrees, which gets me to this point here. I draw my triangle to the x-axis, and I know that this is the angle that I'm dealing with. That would be 60 degrees in there. So I'll draw this triangle out a little larger. That's 60, that's 30. I know that's going to be a half. Root 3 on 2, that's 1. And I'm dealing with sine here. Again, don't forget your cast labels. I'm going to show my working out here. I know that I am in the A quadrant where everything is positive. So sine of 7 pi on 3 is going to be a positive value, and it's going to be the opposite over the hypotenuse, which is going to be root 3 on 2. Now, if you put this into your calculator, you're going to get a value of 0.866 recurring, which is equal to root 3 on 2. So you get it correct.